For thousands of years, humans have looked at the night sky and wondered, what lies beyond? We've crossed oceans, mapped continents, reached the moon, and sent our machines to the edges of the solar system. But these milestones, while extraordinary, are nothing compared to the next great question humanity is preparing to ask. Can we ever leave the Milky Way galaxy? Not metaphorically, not through imagination or philosophy, but literally breaking out of our home galaxy and entering the vast, unthinkable ocean of intergalactic space. If that seems impossible, you're right. At least for now. But there is one idea, one loophole in the fabric of space and time, that just might make it possible. Wormholes. What are they? Can they exist? Could humans one day travel through them, and escape the Milky Way forever? Today, we dive deeper than ever before. This is the story of how humans might someday leave our galaxy. Part 1. The prison of our galaxy. Scene: a panoramic view of the Milky Way, rotating slowly. Before we even consider leaving the Milky Way, we need to understand just how massive, powerful, and restraining our galaxy really is. The Milky Way is not just a collection of stars, it's a gravitational fortress. Diameter: about 105,000 light-years. Stars: roughly 400 billion. Dark matter halo: extending far beyond what we can see. Black hole at center: Sagittarius A*, 4 million solar masses. And humans. We're a tiny civilization living on a small rocky planet in one corner of one arm of this enormous structure. Scene: zoom into the solar system. Our sun, together with all its planets, is orbiting the galactic center at 828,000 kilometers per hour, so fast that we complete one lap around the galaxy every 225 to 250 million years. Yet even with this tremendous motion, we're deeply trapped. Why? Because gravity is the ultimate jailer. The Milky Way's gravitational pull is so strong that to escape it, a spacecraft would need to travel at 2 million miles per hour, or roughly 3,600 kilometers per second. For comparison, fastest human-made object, Parker Solar Probe. Speed: 700,000 kilometers per hour, only 0.06% of escape speed. We are slower by a factor of 50. And this isn't just a technology issue, it's an energy problem, a physics problem, and a foundational limitation of our universe. Part 2. The limit of speed and time. Even if we built engines 1,000 times stronger than today's, we face a fundamental cosmic speed limit. Nothing can travel faster than the speed of light. Light travels at 299,792 kilometers per second. A number so large it's nearly impossible to grasp. And even at that godlike speed, crossing the Milky Way from one end to the other takes 100,000 years. Let that sink in. If humans traveled at light speed, which again, is impossible for anything with mass, and left the galaxy from our position, it would still take tens of thousands of years. 1 million years to reach Andromeda. 2 to 3 billion years for distant galaxies. Time becomes the enemy. Technology becomes irrelevant. Even imagination feels too small. Part 3. Why regular space travel will never be enough. Scene: futuristic spacecraft accelerating, yet making microscopic progress on a galactic map. Let's suppose humans solve nuclear fusion engines, antimatter propulsion, artificial gravity, cryosleep, generational starships, near-light speed travel. Even then, traveling between galaxies at sub-light speeds is pointless because planets and stars move, galaxies drift and collide. Dark energy expands space faster than we can chase it. It's like trying to swim across an ocean that is endlessly widening. No conventional spaceship can overcome this. So what does that leave us? We need something that doesn't obey the rules of normal space, doesn't require accelerating through distance, doesn't care about the speed of light. We need shortcuts in space-time. Part 4. Enter the wormholes. Scene: a grid-like fabric of space curving inward to form a tunnel. A wormhole, also called an Einstein-Rosen bridge, is a hypothetical tunnel connecting two distant points in space-time. Instead of moving through space, a wormhole lets you jump across it. Imagine the galaxy as a sheet of paper. Put two dots far apart. Now fold the paper so the dots touch. That fold is what a wormhole does. Distance becomes irrelevant. Time becomes irrelevant. The Milky Way becomes just another coordinate. Part 5. Are wormholes real? Scene. Einstein's equations animate on screen. Wormholes were first predicted in 1935 by Albert Einstein and Nathan Rosen. Their equations didn't prove that wormholes exist, but they showed that they are allowed by the mathematics of general relativity. Later, physicist Kip Thorne took the idea further. He asked, what would it take for humans to travel through a wormhole? The answer shocked the world. Wormholes could be real, but they're unstable. A natural wormhole would collapse instantly. It would open for a tiny fraction of a second and then snap shut. Any spacecraft inside would be crushed, vaporized, or trapped forever. Unless we found something called exotic matter, a form of matter with negative energy, negative mass, repulsive gravitational force. This bizarre substance could theoretically hold a wormhole open like supports holding a tunnel. But exotic matter remains hypothetical. Not impossible, just undiscovered. And the universe surprises us constantly. Part 6. If wormholes exist, how would humans use them? Scene. A massive ring-shaped wormhole generator floating above Earth. Let's imagine for a moment that exotic matter is discovered. Humans decide to build a wormhole gateway. The scale would be unimaginable. Size. A stable wormhole large enough for spacecraft might be 1 to 10 kilometers wide, surrounded by electromagnetic containment rings, powered by energy equivalent to a small star. Technology required: stellar-level energy harvesting, space-based megastructures, quantum stabilization, precision gravitational engineering. In this scenario, the wormhole would act like a tunnel between two distant regions. You enter from a station near Earth, and emerge instantly somewhere on the far side of the Milky Way. Or even outside it. Part 7. The journey beyond the Milky Way. Scene. A spacecraft entering a glowing wormhole mouth. Imagine the moment. The ship approaches a shimmering sphere in space. From the outside, it looks like a floating mirror, a window showing another starfield, a distortion, like heat waves in the air. And then, you cross the event horizon. Inside the wormhole, there is no up or down, no left or right. Space bends in ways the human mind struggles to understand. Physics becomes fluid, time stretches, light curves. The laws of nature behave differently. And then, you emerge, not 50,000 light years away, not even 100,000 light years away, but completely outside the Milky Way. Before you lies the most beautiful and terrifying sight a human could ever witness. The entire Milky Way galaxy hanging in the dark like a glowing spiral of fire. Part 8. The ocean between galaxies. Scene. A spacecraft drifting through intergalactic darkness. Leaving the Milky Way is one thing. Surviving outside it is another. Intergalactic space is 100,000 times emptier than the inside of galaxies. Almost pure vacuum, filled with ghost-like hydrogen atoms. Lit only by distant galaxies. Dominated by dark matter, expanding due to dark energy. This is the true cosmic wilderness. Out here, no nearby stars, no habitable planets, no comets or asteroids, no cosmic neighborhood, just silence, and darkness, and eternity. Part 9. Why would humans leave the Milky Way? As crazy as it sounds, there are real scientific reasons we may someday need to leave our galaxy. The future collision. Milky Way versus Andromeda. In 4.5 billion years, the two galaxies will collide. Stars will be thrown around like grains of sand in a storm. Humanity, if still alive, may need to escape disaster. Cosmic disasters, gamma-ray bursts, supernovae, or rogue black holes could make regions of the galaxy uninhabitable. Expansion of civilization. If we become a Type 3 civilization on the Kardashev scale, we may spread across multiple galaxies. Scientific curiosity. Humans have never stopped exploring. The galaxy is simply the next great frontier. Part 10. The roadblocks to wormhole travel. Even if wormholes are possible, humans face enormous challenges. Exotic matter. We have not discovered it yet. But quantum physics hints it might exist. Energy requirements. Opening a wormhole may require capturing entire stars. Stability. A wormhole could collapse mid-travel, trapping or destroying travelers. Time dilation. Some wormholes create time loops. Travelers could return before they left, or never return at all. Cosmic threats, radiation, gravitational shear, quantum turbulence, all could be fatal. Engineering. Building a wormhole is beyond anything humanity has ever attempted. But none of these challenges are proven impossible. Part 11. Could aliens have already done it? If ancient alien civilizations exist, and if they are millions of years older than us, they might have already solved wormhole travel. In fact, some scientists believe fast radio bursts, cosmic filaments, strange gravitational anomalies could be signs of massive cosmic engineering. The universe may be filled with civilizations hopping between galaxies using shortcuts we can't yet understand. Perhaps we simply haven't learned to see the signs. Part 12. Final question. Will we ever do it? So now we return to the question. Can humans ever leave the Milky Way galaxy? Here is the most scientifically honest answer. Not with rockets, not with fusion, not with near-light speed travel. The only technology that could ever allow humans to escape the galaxy within a human lifetime is wormhole travel. It is our only loophole in the laws of physics. Will we build wormholes one day? No one knows. But here is the truth. Humanity has a history of achieving what once seemed impossible. Flying, space travel, quantum mechanics, artificial intelligence, mapping the universe. Every breakthrough began with a question. And so we ask again. Can humans ever leave the Milky Way? Maybe not today, but someday. When we master gravity itself. When we open the fabric of space. When we step through the first cosmic doorway. Humanity will look back at the Milky Way, not as a home, but as the place where our journey began.